Yeah, so my name is Garrick, and for those of you I haven't met and thinking I might look a bit familiar, you might have seen a presentation by my old man at some point, Dorian, and I know that having spent a lifetime learning genetics from him, that sometimes it can be like drinking water from a fire hose. So I will try to hopefully haven't inherited that trait from him. So first, a little bit about me, just to introduce myself. So I was the black sheep in the family in that I didn't go into animals or genetics. Both of my siblings studied sort of animal science and animal ecology, and I decided I wanted to go into engineering. So my background is all aerospace engineering. I did an undergrad and PhD at Iowa State, and spent a summer in Philadelphia working on the V-22 Osprey, which is that aircraft there on the right that the Marines use. And my PhD research was on fuel spray and scramjets, which is basically my PhD could be summed up in a 30-second video clip. It would be that image there on the left. But basically, we were looking at fuel spray inside rocket engines. And you might be wondering what that has to do with genetics. And this is a clip from the new Top Gun movie where Tom Cruise blows himself up in that new plane, which had scramjet rocket engines. But effectively, the numerical methods we use to simulate fluid mechanics are the same numerical methods we use to solve mixed model equations, which give us EPDs and accuracies. So as I was finishing up my PhD, Dorian and his colleague Bruce Golden, who many of you may also know, had started a company around 2014 called Theta Solutions, to develop a piece of software called Bolt in order to perform single-step evaluations. And so as I was finishing up my PhD, they'd gained enough business that they asked if I was interested, and I knew enough about what they were doing that it sounded pretty exciting, and I haven't looked back. So that's where we are today. So our goal at Theta Solutions, and I should also mention, we've got a sibling company based in New Zealand called Helical, which during COVID, I was kind of stuck in New Zealand. We literally couldn't get out. And so I set up a company there so I could hire on some employees. And effectively, they both companies do the same thing, which is we consult and we develop and provide software for genetic and genomic evaluations and for the information systems that surround genomic evaluations. So ultimately, our goal is to turn your data into business value, which effectively means, provided you've got some kind of breeding objective, which is ultimately, hopefully, something along the lines of increasing your profit, then, going through the whole process of collecting data on your animals, collecting genotype data, getting that sent to the lab and collecting the data back, that all feeds through into a genomic evaluation system. And that's really where our software sits, as the data analysis components of that process. But we have a lot of know-how of all of those steps in between and what's involved. So what is Bolt? Bolt is one of our core products, our first product. And occasionally I overhear sort of a misconception about Bolt, which is that it's a model, but it's not a particular type of model. Bolt is actually a general type of software that could fit any kind of model. That could include pedigree-only models, so what we call a PBLUP, where you only have pedigree and performance data. It could include what we call a marker effects model, which is sometimes referred to as a SNP-BLUP model or a SSMEM model, single-step marker effects model. Or it could also solve what we call a GRM type model, where you're fitting a genomic relationship matrix, also known as GBLUP if all of your animals are genotyped, or SSGBLUP if you're doing a single-step model. Now, one of the unique things about Bolt is it takes advantage of graphics processing units. So all the rage these days around AI and ChatGPT, those are all powered by graphics processors. And we've been taking advantage of that same hardware since 2017, because that type of hardware is extremely good at matrix algebra calculations. And that's the type of calculations we have to do a lot of in order to solve mixed model equations and evaluations. And so just to give a bit of a timeline of what happened with Bolt, it actually originated from a piece of software called ABTK, Animal Breeders Toolkit, in the early 1990s. And in 2011, when Bruce Golden and Dorian were first talking about single-step evaluations and what could be done, they resurrected ABTK and used GPUs to accelerate a lot of the computations in order to incorporate the genomic data into that. And since 2017, Bolt has been powering weekly single-step evaluations on tens of millions of beef cattle globally. So just to give two examples you may be aware of, one you may not be. So one is the American Hereford Association analysis, which was first released in December 2017. That includes data from American Hereford, Canadian Herefords, Argentine Herefords, and Uruguay Herefords. And that analysis includes about 3.8 million animals in the pedigree and more than 200,000 genotypes. And there's about 17 traits that are being analyzed there every single week. Likewise, the IGS analysis also uses Bolt software. That was first released in May 2018. That's the largest beef multi-breed analysis in the world and encompasses data from more than 20 breed societies. Might have that wrong, Jackie. Seems to update pretty regularly. And I think that pedigree is now more than 20 million animals in total. And I think they're now well past 500,000 genotypes across 14 traits, which also runs once a week. So collectively, those two analyses represent two of the three major US national beef evaluations, and obviously both American Hereford and IGS also include other cattle from around the world, not just within the US. Now, the other big project that's been keeping us busy the last couple of years is the New Zealand National Dairy Evaluation, which is also using our Bolt software. And in December 2021, they released the first iteration of that software using Bolt, which was a fully pedigree-only analysis. And we have since then been working on converting all of those pedigree-only analyses to genomic analyses. And that's proved to be an interesting process because it's a very, very large multi-breed analysis. There's more than 34 million animals in their pedigree, and not quite as many genotypes, just getting started, but still about 70,000 genotypes. But that's across 27 traits. So a pretty substantial amount of data that goes into that, and a huge amount of data, particularly for things that are measured once a day. In terms of the milk production traits, which are measured routinely, there's more than 250 million phenotypes just for the milk production traits, for instance. So taking a step back again, the origins of Bolt and one of the other things that makes it unique. So starting in the 1990s with ABTK, which was the Animal Breeders Toolkit, developed by Bruce Golden. That piece of software was open source, and in the 15 or 20 years that was widely used, there was not really any outside contributions from anyone, except one time someone converted it to run on Windows. And so that was one of the things when Dorian and Bruce started developing the Bolt software. They realized very early on that in order for the software to continue to innovate and to be developed into the future, it would have to go into a paid licensing model. And one of the other unique things was that prior to ABTK, most evaluation software were what we call black box models. So there was one big piece of code which did one particular evaluation on one particular trait, and anytime you wanted a new trait or wanted to make changes to that code, you had to copy all of that code over and then make your changes in there. So it was a very costly and inflexible way of maintaining that software and running those evaluations, and it resulted in a lot of duplicated effort and code. Now, the concept with ABTK was that it would be a toolkit. So you would have lots of different tools that did different pieces of the process. So you would have one tool which takes in a pedigree file and computes inbreeding. You'd have another tool which takes the pedigree file and computes the inverse relationship matrix. You'd have other tools for dealing with the phenotype files and so on. And by piecing all of these different tools together into a pipeline, you could then create a set of tools which could be reused across many, many types of evaluations. And at the time, it was something that changed the concept about how some of these softwares should work, and enabled a lot of development in terms of the evaluations. So in early 2011, as I was saying, Bruce and Dorian got started on looking at ways to perform single-step models. So at the time, models which were using genomics were all multi-step. So there was a pedigree-only model, and there was an analysis using only genotypes, and then there was a step which combined the predictions from those two separate analyses to give you your final EPDs. And so it was called multi-step. So the concept with single-step was that we would move to a single analysis which combines all of your genotypes and your pedigree and your performance into one model, with both your animals who are genotyped and your animals who are not genotyped, to get your EPDs in one step. And effectively, Bruce and Dorian, they took that original concept of ABTK and resurrected it into a suite of tools, which they then GPU accelerated the heavy ones to deal with that genomic data, and introduced a number of new tools for more accelerated solving of the EPDs, and more accelerated what we call Gibbs sampling, which is how we compute the reliabilities and the accuracies. And this enabled them to move forward and to work with organizations like American Hereford and IGS to implement weekly evaluations with Gibbs sampling to produce accuracies and EPDs on a weekly basis. So the second major revision of BOLT was around 2017. So I joined in January 2017, and one of the things I worked on was upgrading what we call the PCG solver, so the preconditioned conjugate gradient solver, to fit different types of preconditioners, and that allowed us to reduce the runtime. So what that means in practice is for things like the dairy evaluation, even in models with almost 35 million animals, and models where we're fitting up to 7 traits, we're still able to turn around EPDs and accuracies, within only a few hours. And a lot of those models, which are single trait, we can do in only an hour or two. And for even the really big models with 7 traits, we're able to turn around in less than 12 hours. So some of the other innovations were just abstractions to enable more flexibility in terms of the models that we could fit, and extend functionality of a number of the tools. And collectively, all of these developments enabled us to substantially reduce the development effort in order to set up new models, and also to substantially reduce the production runtimes on a number of those bigger models. So the most recent release, and this is the last piece on BOLT that I'll be talking about, but most recent release, we supported the latest generation GPUs. So one of the unique things about BOLT is that without making any changes to our software, as all of the other functionality in the world that's using these graphics processors, so with all the advances in AI and self-driving cars, which are all using the same hardware, what's happening is there's billions of dollars being put into researching how to make these graphics processors run faster. And when a new graphics processor comes out that's even better than the previous generation, our code can run on that without any changes, and everything just runs faster. So we're taking advantage of all of that investment that's going into those graphics processing units. And that enables us to be able to run a lot of these huge analyses on effectively kids' gaming computers, because one of the other uses for these graphics processors for kids to play video games. So yeah, we're just taking advantage of all of that investment. But ultimately, one of the key focus in terms of direction for all of our developments is to focus on the ever-growing list of opportunities that are related to the issues that our clients are running into on a daily basis. And so that typically means, looking at new types of phenotypes and how we can fit those in models, new types of genotype data or low pass data and so on, and just different types of models and what are the computing challenges that enable us to come up with new tools which will allow them to fit those models in a routine way. So one of the other big projects I worked on when I first joined Data Solutions in 2017 was a new product for us, which we call Tree. And one of the early challenges we discovered as we were rolling out software for single-step analyses was that no organizations had any kind of software for dealing with genotype data. And so we put together a piece of software which enabled us to collect genotype data from multiple different genotyping laboratories, to prepare that data to feed it into single step, and then also to build a web interface in front of it so that people could submit a pedigree file, so animals and their sires and their dams, and that system would return back to them the parent verification results and parent discovery results for those animals. Because at the time, as I'm sure a lot of you are aware, that a lot of the breed societies were transitioning to SNPs from microsats, and that was driven partly by single step, and it was also driven by the parent verification, which many societies had started putting into their bylaws that animals had to be SNP parent verified in order to register. And so very quickly, this product grew to be a substantial piece of business for us. There's now more than 24 breed societies around the world and a number of other organizations using this system across more than 5 species and 4 continents to aggregate all of their genotype data from different laboratories and to enable them to easily use a web system to run all kinds of analyses on that genotype data. Now, after running that product for a few years, maybe 4 or 5 years, I realized that within the distant future, 5 to 10 years, we could expect to see potentially millions of animals getting genotyped and at higher and higher densities. And so I quickly realized that the system that I first put together would eventually reach some limits and slow down. And so we decided to sit down and basically start from scratch to develop a new system, taking everything we'd learned over the last few years and looking at everywhere we could expect to be in the next 10 years, and put that into a new system, which would be API first, would be web accessible, and basically be a completely modern piece of software to enable us to go into the future and deal with the increasing amounts of data that we expected to see. And so that product is what we call Helical. And it says another quantum leap there because when bulk first came out, it was described by some as a quantum leap from ABTK to bulk. So I would call this another quantum leap in terms of what our old products could do versus what the new product can do in terms of managing genotype data in real time. And as I said, one of the first pieces that sort of led to its sudden growth that we saw across a lot of the societies was many of them wanted to use or were using multiple different genotyping providers. And for those societies that were relying on the genotyping provider to make their parentage calls for them, that meant that they were somewhat limited to always forever use that genotyping provider into the future, because they were relying on the genotype data from all the historical animals to be in their database. So any new animals they genotyped also needed to be going to that same place so that they could continue to get those parentage calls. And so for any of the societies that wanted to lift up and switch and start using a different lab, we could offer them a solution, because effectively we could take all of their historical data and put it in the system, and then we could take all of their new data and start loading that into the system, and then they could run parentage verification and discovery across all of their data between those 2 different labs. So collectively, we then, once we built out those pieces, we architected the system in a way that we could add on additional modules. So we can add on information relating to pedigree and phenotype and EPDs, because we could see in the future that one of the other things that were holding a lot of people back when we were dealing with them in terms of getting them up and running with evaluations was their information system. So basically that just means they've got all of this data and they need to get that data from here to somewhere else, which is where they want to run their analysis on it. And then they want to get the results from that back into their information system to display those results. And so we started adding modules to effectively do a bunch of those pieces. So to give a schematic, I suppose, of what that whole process looks like. Effectively, you've got some value proposition, which is EPDs or indexes, genetic improvement, ultimately. And in order to affect that change, you've got some kind of data input pipelines you have. So you're measuring traits, you're taking genotype samples on animals, and all of that data needs to be aggregated into some kind of information system. And so that information system could consist of multiple different databases that different people are running for you. It could be in one single database, but ultimately you need to be able to store your pedigree data, your trait data, your genotype data, and also your results so that your breeders can access that information. And ultimately, it doesn't, as I said, it doesn't matter whether those are all stored in the same system or on different systems. But what you need to be able to run an evaluation is to be able to extract pedigree data and performance data out of those systems to feed them to the evaluation system, whatever that may be. And then once that system computes the EPDs and accuracies, it needs to be able to feed that back into your information system so that your breeders can make selection decisions using that information. And so our original focus was that evaluation system at the bottom there, the bulk piece. But as I said, what we quickly realized was one of the biggest bottlenecks for us to get a new evaluation up and running for people or for getting a new client was that their information system made it very hard, if not impossible, for them to get the data out that they needed to get out to run a new evaluation. And it was very inflexible or expensive for them to add a new place for them to put those results in a location where people could quickly access them and start making use of them. And so that's why we've since expanded. As I said, we've got the Bolt software, which is all about evaluations, and we've now got this Helical software product, which is all about the entire ecosystem, but specifically the information system relating to storing genotype data, storing trait data, pedigree data, and results. So to break that down a little bit more, in terms of what the platform looks like, there's that database modules for storing the different pieces of data, the genotype data, pedigree data, performance data. There's an analytics engine underneath, which can include evaluations. And then there's an administrative web interface sitting on top of all of that. So all of the data can be managed by a web interface without much technical skills. You don't need to be a geneticist to be able to put the data in and pull that out. And sitting on top of that is a public interface, which can optionally be turned on, which enables the public to go in and look up information about animals. There's also a breeder interface where a breeder can log in and look up information on just their own animals, and they can also submit information on their animals. And then there's also an area where we can hook in with genotyping providers, and we've worked with pretty much every genotyping lab you can name over the years to enable genotype data, which is collected by your farmers, to automatically be imported into the system as soon as it's available. And we've designed the system to be agnostic to labs and also to be very flexible in the sense that pretty much every single one of our clients has their own information systems already. And so no matter which of the pieces of our system they may need or want, we can hook that into whatever kinds of systems that they already have in existing. So even if all they want is a place to store their genotype data, then that's fine with us. So one of our big clients since 2017 would be the Australian Wagyu Association. And I pulled this slide from a recent presentation they gave when they were talking about this new system of ours and how they're using it. And they call it their one-stop DNA shop. So effectively, what it allows their members to do is to log in and create a DNA test request, so they can choose whether they want to genotype their animals at Zoetis or Neogen or Weatherby's or whoever, and they can choose what add-ons and what additional defects they want to include in those tests. And once they create that submission, it's then sitting there in the system, so that when the DNA data is returned from the lab into the system, it immediately links everything up and notifies that farmer that that information is there and ready for them to look at. And then as soon as the Australian Wagyu team has completed the parent discovery, they can log in and they can look at what the parent discovery results are. They can look at what the genetic condition results are that have been returned. They can look at genotype call rates and any other quality control we do on the genotype data. And they can also look at results on what they call the crossbred Wagyu test, which is a test which allows them to see what the Wagyu content is of any animal. And it's also a place where they can view what they call the Wagyu feeder check results, which is a particular product that Australian Wagyu has used that I think the concept could apply quite well to a number of organizations around the world. And effectively what that concept is a data flywheel, which is enabling a lot more carcass data to feed back to the breed societies. And so the feeder check product is aimed at commercial cattlemen who are feeding cattle out, and they effectively genotype the animals and they get back what they call a feeder check score, which is basically an index on a number of carcass traits. And those cattlemen can then use that to decide which animals should go onto the slow path versus the fast path. And it also enables Australian Wagyu to run parent discovery to link those animals back to the registered bulls in the society system. And those commercial producers are then also incentivized to provide carcass data back to the society when they process those animals. And that carcass data can then improve the carcass evaluation for the society. And it's also used to improve those carcass trait predictions for the next batch of feeder cattle that go through. And so it's created this really nice self-fulfilling value chain where both the society and the commercial cattlemen are getting value out of these genotypes. And so just to give a bit more of an example about sort of some of the things they see out of that system when they get the data back. So effectively there's 5 traits that are feeding into that feeder score. There's marbling score, feedlot average daily gain, carcass weight, eye muscle area or ribeye area, and scanned fat. And the Australian Wagyu Association put together different economic weights for each of those traits in order to create a single feeder score, which those farmers can then use to rank their animals and help them make selection decisions or culling decisions about those animals on the lot. And all of that is handled through the web system that we've built. And we've also built out functionality so that once the parent discovery piece has been completed, those farmers can also log in and view summaries on sires, so they can aggregate the information based on all the progeny out of some sire and get an idea about which of those sires are higher performers or not, just purely from the feed prediction. So just to give a couple of quick snapshots of what the system sort of looks like for any one of our clients. Effectively, we've got an administrative interface where an organization can log in, they can look at all of the animals they have in the system, they can look at all of the entities that are in the system, and an entity is some kind of organization which owns animals. The animals don't have to belong to an organization, but if they do, it means that you can add users to an organization so that when they log in to the breeder area, they can see all the animals that belong to them, all of the animals' data that belong to them, and they can also submit data on those animals or on new animals as well. But effectively, all of the data is managed through the administrative side of the system. And just to give an example of what the breeder interface looks like. This is actually the public interface, but the breeder interface looks very similar when you're looking at any one particular animal. So any of the fields that are stored in the system can be chosen to be populated through to the breeders or to the public, and they can log in. So in this case, we've got an example of a 3-generation pedigree here with some information on those animals. We've got an area where they can look up breeding values or EPDs, and this all populates through into their system as soon as the evaluations finish running. And then there's also a public interface where any animals which are registered and which the society deems to be allowed to be made public can be searched for, and there's all kinds of filters in there to enable them to search based on certain criteria around breeding values on different traits. And they can also query out all the information about the EPDs and accuracies that have come through for any animals that are in their system. And we also added an area to create sales catalogs. So effectively, any animals within the societies that they're wanting to sell, the farmer can just put in the list of IDs that they want to sell. They can upload photos and add some descriptions, and then also add any links to any auctioneering or bidding sites that are being used elsewhere. And that automatically will then pull through any of the EBVs or reliabilities on those animals for the traits that they've been evaluated on. So ultimately, our focus is on innovative software for genetic improvement. And originally, our core focus was on the evaluation software, but we quickly realized that there's sort of a limited scope in terms of the market about what we can do in terms of evaluations. And one of the biggest limiting factors for us to get new evaluations up and running was the information systems that people have. And the other thing we've seen over the last 10 years is a real huge growth in terms of the amount of data that's being recorded and the people who are recording that data. And in particular, in the last couple of years, we've seen a huge growth in the number of commercial cattle that are getting genotyped. And a lot of that genotype data is getting used in certain instances, or they might be getting predictions from the lab, but then the genotype data is being delivered to some of those commercial producers and just sitting in folders on their desktop. And effectively, there's a lot of value still sitting there in that data that could be made use of with a system like that, like ours. But we also see that there's a lot of opportunities in terms of other kinds of data providers that are starting to pop up. I saw some breeder people walking around earlier. There's a number of other software providers like that, where there's all this data being collected by all these different parts of the industry. And there's going to be more and more of a need to figure out how to aggregate all of that data together to get it back into a place where it can be used in genomic prediction and provided to any number of evaluation providers. And I think going into the future, we're probably likely to see a situation where any one organization may get evaluations on different traits from different providers. At the most part, at the moment, we're still seeing, one provider is providing the evaluation for all the traits for people, but as more novel traits come up, and particularly some of those harder to measure traits or expensive to measure traits, where there's going to be certain localized data sets that people have that can add value to others, there's going to be more and more opportunities to integrate all of that data together in a way that can unlock value for more people. And as I said, the biggest limiting factor there is the information system. And so that's an area where we see that there's going to be a lot of opportunity in the future to improve genomic predictions going forward. Thank you.